Evolution is wonderful because it always adheres to a strict set of natural, completely logical laws. Everything makes perfect sense, from whales to identical sloths who are vastly unrelated. Dogs have built-in paw warmers. Canines have evolved with built-in paw warmers or snow booties that act similarly to seat warmers in luxury automobiles. This provides dogs the unique ability to keep their feet from freezing even on frosty or snowy terrain. A dog's bare paws are exposed to the environment and have a high surface area to volume ratio, which should increase heat loss. However, a dense network of blood arteries keeps dog feet warm in almost any terrain. The veins and arteries are so close together that heat from warm blood traveling to the paws quickly transfers to colder blood leaving the paws, keeping the extremities warm. Scientifically, this is referred to as a countercurrent exchange system. The penguin feet and wings, dolphin fins, and Arctic fox paws all use the same mechanism. Its unexpected discovery in canines shows that dog domestication originated in cooler climates. Additional insulation comes from freeze-resistant fatty reserves situated within the pads, though excessive breeding has reduced this in some dog breeds. Penguins can't taste fish anymore. In a terrible twist of evolution that occurred some 20 million years ago, penguins appear to have lost the ability to savor fish, their favorite feast. They still eat seafood, but it might as well be iceberg lettuce. The taste receptors that detect umami, the full-bodied, meaty taste found in fish and other delectable creatures, are no longer encoded in the penguin DNA. According to a genetic investigation from the University of Michigan, researchers hypothesize that living in a freezing habitat has reduced penguins' capacity to experience a complete spectrum of flavors, citing the fact that taste receptors operate poorly at low temperatures. As a result, the largely useless sensors gradually vanish from penguins' mouths. To make matters worse, the sweet and bitter taste receptors appear to be non-functional. We don't even know if these unfortunate animals can detect sour and salty tastes. In penguins, the structure for savoring salty flavors is also necessary for renal function. As a result, it may not work for penguins' sense of taste, rendering them unable to perceive any flavors. 2- and 3-toed sloths are not really related. Sloths with 2 and 3 toes are so closely alike that scientists were surprised to discover the similarities were entirely coincidental. The shiftless sloths are only distantly connected to each other, making them an excellent example of convergent evolution. Both are xenarthrans, which are believed to have descended from land-dwelling, clawed animals such as anteaters and armadillos. Instead of toppling anthills, antediluvian sloths use their formidable claws as climbing spikes, colonizing treetops, and establishing a new evolutionary niche as lethargic arboreal mammals. Except for cycle-like claws, ancient terrestrial sloths exhibit little resemblance to their current cousins. Modern 2-toed sloths, for example, are most closely linked to the extinct megalonyx, a burly, dopey-faced mammal with a 3-meter, 10-foot body span and an occasional appetite for meat. 3-toed sloths, on the other hand, appear to be miniature counterparts of the megatherium, an astonishingly large ground sloth that could reach 6 meters, 20 feet, in length. Fortunately, these enormous bodies evolved to reach out-of-the-way flora, as predatory sloths plummeting from the canopy is a terrible prospect. Snakes came from below. Almost everyone despises snakes, and until recently, it was considered that their disgusting, writhing bodies evolved millions of years ago in distant, sea-dwelling relatives. Others suggest that the agile, limbless bodies evolved as an adaptation to underground life, similar to the vermicular monstrosities from the Tremors franchise. Paleontologists Hongyu Yi and Mark Norell have published an anatomical research that appears to relegate ancestral snakes to the underground domain of moles and earthworms. The secret resides in the form of a snake's inner ear, which allows researchers to determine its preferred biome. Burrowing animals have expanded inner ear structures that detect low-frequency rumblings caused by critters moving through Earth. An X-ray examination of 44 fossilized and current reptiles revealed that the telltale inner ear bubble was strongly represented, indicating a below-ground provenance. This latest discovery supports previous research by John J. Weens of Stony Brook University, who delved deep into the reptilian DNA to identify the progenitors of most modern snakes, blind, ground-dwelling proto-snakes known as scolopendrians.